Hi guys, this is Karim Amir from Handbook. Today I'm going to introduce a new course from ASHRAE, High Performance Building Design Professional or HBDP. It is a top credential in ASHRAE certification program because it covers the major ASHRAE standard guides and handbooks. So if you go to ASHRAE website here and click on certification, if you may know, ASHRAE has 7 different certification programs. 4 of this certification about building design like PMB, CHD, HFDP, and HBDP, our course today. 2 of them for building performance, PCXB and BEAB. Last one for building operation, OPMB. So here let's have a look for the candidate handbook to know the eligibility, who can sit for the exam, how much fees for application, what is the exam contents, and what is the required reference in order to prepare for this examination. So first of all here, to be eligible, you should have bachelor degree plus 5 years of work experience in the field, or you have a PE license or any registered professional license in your country. Regarding the application fees, if you are ASHRAE member, you have to pay $395 American dollars. If you are the member, you have to pay $595. About the exam reference, to prepare for the exam, as per ASHRAE recommendation, you have here ASHRAE practice exam, design guides like ASHRAE green guides, advanced energy design guide for small to medium office building to achieve 50% energy saving or 30% energy saving or net zero energy building, and also same standard but for retail building. Standard and the guides like ASHRAE standard 55 for thermal comforts, ASHRAE standard 62.1 for ventilation for acceptable indoor air quality, ASHRAE standard 90.1 either imperial or metric for building except low rise, and ASHRAE standard 90.2 for low rise building, ASHRAE standard 189.1 for high performance green building, and the ASHRAE guidelines 0 for commissioning process, 1.1 for commissioning of HVAC system, ASHRAE guideline 4 for operation and maintenance, ASHRAE guideline 14 for measurement of energy and demand saving, and ASHRAE standard 90.1 user manual. Also ASHRAE e-learning like fundamental of standard 90.1, ASHRAE Learning Institute like fundamental of standard 62.1, fundamental of green guides, advanced energy design guide for small retail building and small office building, ASHRAE standard 90.5, commissioning process for new or existing building, and complying with the requirement of standard 62.1. As you see, many references required to prepare for the exam because it is a top credential, as we mentioned. Once you sit for the exam, you will have report pass or didn't pass. If you pass, you will receive email with your badge and you can print your certificate from the website like Credly. Score pass for the exam 63% to pass the exam, and to date the pass rate for the people who sit for the exam around 62% because it's a difficult and hard exam. Regarding the blueprint or exam contents, in order to know the body knowledge or body of knowledge required for the exam, the first part here about background information, it has 18 questions in the exam, like sustainability process, concept, HVAC process. Second part about energy analysis, 22 questions in the exam, like envelope, mass orientation, assessments, ventilation, energy compliance modeling. Third part, indoor and site improvement, 17 questions about thermal comfort, air quality, and lighting. For the part about control and monitoring, 14 questions about control strategy and hardware. Benchmarking with performance metrics, 7 questions in the exam about project performance measurement and energy performance verification, environmental performance measurements. Then water conservation, 8 questions about stormwater management, domestic water management, and the process wastewater management. Commissioning and sustainable construction, 7 questions, include documentation and commissioning process. Last part about energy and material use and management, 7 questions. So total you have 100 questions marked and 15 questions unmarked. As you know, ASHRAE has 3 types of questions: recall, application, and analysis. So total question for recall, 34, application, 46, and analysis, 20. So it was a quick overview for the Candidate Handbook. If you want to prepare by yourself, you should focus on this body of knowledge and prepare from the references mentioned here as per ASHRAE recommendation. So in our course, the course outline, it's 10 lectures, around 20 hours. As we said, HBDP, it covers many aspects of the building, and it is a trend now because it's focused on net zero building, green building, sustainable building design, and high performance building design. As you know, all standard and codes now, they are enforced this approach in order to achieve net zero building in 2050. So our course here consists of 10 lectures. The first lecture about HVAC fundamentals. We're gonna discuss heat transfer, pump break horsepower, degree days, air system, hydraulic system, climate zone, and HVAC zoning. Second lecture about ASHRAE standard and guides, like 90.1, 189.1, Green Guide, 55, 60.1, 0, 1.1, 202, and Advanced Energy Design Guides. Third lecture about environmental, indoor environmental quality, like indoor air quality, thermal comfort, lighting, and acoustic control. Fourth lecture about building efficiency. We're gonna discuss building envelope, HVAC system, lighting, service, water heating, and the black power. Fifth lecture about water conservation. We're gonna discuss domestic water use, rainwater harvesting, grey water, and the cooling tower system. Sixth lecture about material management. We're gonna focus on life cycle analysis from cradle to cradle or cradle to grave, recycled and salvage material, construction waste, sustainable procurements in terms of mandatory, prescriptive, and performance. Lecture number 7 about sustainable building and sites. We're gonna focus here on the heat islands effects in the urban cities, exterior or site lighting, stormwater management like runoff reduction and the collection of stormwater and rain garden, and landscape irrigation and calculation. Lecture number 8 about sustainability, benchmarking, and metrics is very important. We're going to here have in-depth details about net zero energy building, how to achieve it, design approach and features. Also, we have the measurement of energy using international performance measurement and verification protocol and the ASHRAE standard 14 for measurement of energy and demand saving. And we have case studies for commercial and office building. Lecture number 9, it will be about control and monitoring. We're gonna discuss here the control strategies for heating, cooling, like control of temperature, humidity, and enthalpy, control hardware and PID, DDC, building system level, and unit level, and the energy simulation software or programs as recommended by ASHRAE standard 140 for testing of this program. Last lecture to be about commissioning, project management, operation, and maintenance. So here, if you want to have detail about these lectures, the first lecture here will be about HVAC fundamental. We're gonna cover all these aspects. Thermal comfort, we'll have overview about ASHRAE standard 55 and the main 6 factors, 4 of them environmental and 2 occupant or personal. And also we'll have here overview or quick overview about the graphical methods and PMV and PBD for thermal comfort and surveying in any building. Heat transfer, we're going to discuss here the U value and different equation formula required for sensible latent heat and U value, R factor, C factor, and F factor. For degree days, we're going to here focus on how to calculate heating degree days in winter, cooling degree days in summer, and the base temperature. Then we have the pump affinity laws and the pump brake horsepower and the impact of flow rates and pressure on the brake horsepower. Also, we have fundamental of load calculations in summer and winter and psychometric in order to know all process and the status of HVAC process in psychometric chart. Then we have the air system schematic and types of system required, like 2 pipe, 4 pipe, fan coil units, difference between conditions, indoor, outdoor, in summer and winter for the air. Then we have hydraulic system and different type for heating and cooling, like air-cooled chiller and condensing boiler with a schematic and conditions of water, condenser, water, or chilled water. Then we have the climate zone based on the country, either in US climate zone, like here from 1 to 8, based on numbers, and ABC based on letters. It is cold or hot, dry or humid or marine. Or based on international climate zone. For example, if you are in the Gulf area, what is your climate zone, like 0P in Dubai or Qatar or Saudi? Also, we have some recommendation here about each zone. If you are, for example, in the climate zone number 4, what HVAC system should be selected and installed? What is the requirement for the envelope system, lighting system, power system, service water heating system? Then we have the zoning or HVAC zoning inside your space based on orientation, based on occupancy or function of the building, and based on mechanical system in terms of interior or perimeter zones. For lecture number 2, we have here in-depth detail for ASHRAE standard 90.1 and ASHRAE standard 189.1 in terms of alternative method like energy cost budget method and performance rating method. If you cannot comply with the codes, with mandatory sections or prescriptive sections, you can provide alternative with performance or energy budget cost method, or energy cost budget method. Also, we have overview about ASHRAE standard 55, 6.1, AEDG for a small to medium office building, retail building, green guide and commissioning process standard and guides. So here first we're gonna understand what is the difference between code, standard, and the guides, like different ASHRAE standard here and guides. Then we have in-depth demonstration, and we're gonna open the ASHRAE standard 90.1 and we take all the content and sections. What is the mandatory requirement? What is the prescriptive performance and how to comply with HVAC system, lighting system, power system, service water heating, daylighting, and so on. And also we compare here between energy cost budget method and the performance rating methods in terms of energy cost. Also, we open here ASHRAE compliance form to apply for any project, how you comply for your projects with energy cost budget method using these forms by ASHRAE. Here also the ASHRAE standard 189.1, it's more stringent than ASHRAE standard 90.1, and it requires also renewable energy on site. ASHRAE standard 55, we have here quick overview because we're gonna cover it in detail in the indoor environmental quality in lecture number 3. Also ASHRAE standard 60.1, we have here quick overview about content and sections, but we're gonna cover it in detail in lecture number 3, indoor air quality. Also, we have here overview about content section and chapters for advanced energy design guides for a small to medium office building to achieve 30% energy saving or 50% or net zero, and also for retail building. Also, we're gonna cover ASHRAE Green Guide, the main section and the contents, because it's the main guide for green building. And the ASHRAE standard and the guides for commissioning process, either 0 for commissioning process guideline, or 1.1 for HVAC commissioning process, or standard 202 for commissioning for building and system. Lecture number 3, indoor environmental quality. We're gonna cover here. We're gonna cover indoor air quality, HVAC as per ASHRAE standard 62.1, thermal comfort as per ASHRAE standard 55, acoustic control and lighting as per ASHRAE green guide and 189.1 and 90.1. So here for indoor air quality, we're gonna have a quick first overview about type of ventilation and procedure and calculation. Then we have in-depth detail here about calculation for outdoor air requirement for people and area, and how to consider effectiveness of air distribution based on heating or cooling from ceiling or from floor, and diversity, and also ventilation efficiency. Then we have the filtration and PMs. What is the required merge for filter in order to remove PM10 or PM2.5 micrometer as per standard requirements? For thermal comfort, we have first quick overview about the standard section and the contents. What is the 3 methods in order to comply with thermal comfort condition, like graphical method, analytical method, and natural air controlled method. Also here we have psychometric chart and the acceptability rates, either 80% or 90% based on standard requirement or based on client or owner requirements. Also we cover here acoustic control in terms of noise criteria method in order to comply with sound level inside your office or your building. For lighting, here we have in-depth detail about lighting, either artificially or naturally by daylight. First, we'll have introduction about lighting terminology and terms. Then we have the correlated color temperature, CCT, and color render index. What is the impact of them and how to select them for your application? What is the foot candle and lux, lumens, illuminance, illuminations, efficacy? All these very important terms. And how to calculate daylighting either from vertical fenestration or from skylight and rooftop monitor. What is the primary side lighted area? What is the secondary side light area? What is the obstruction height and head height of the windows or glazing, and ceiling height for the skylight or monitor, steel height. Here also we have the design approach for open office building, how you can here provide the good orientation in order to harvest the daylight based on your climate zone. Lecture number 4 about energy efficiency. We're gonna cover building envelope in detail, HVAC system in detail, service water heating, plug power, and lighting in detail. In terms of energy efficiency, we took already lighting in the indoor environmental quality in terms of light quality and daylighting, but here we focus on lighting in terms of energy saving. So number 1, we have some fundamental about energy efficient design of the building. What is the approach for design? Then we have building envelope. What is the solstice equinox? How the earth revolutes or rotates about the sun or about its axis, and what is the impact of this on your building orientation? What is the sun bath in winter and summer? Which one will require you to provide overhang or shading, and which one will force you to put the daylighting in east, west, or north or south based on your climate zone? We have this in detail. Then we have building envelope thermal insulation, air leakage, and fenestration, either from top like skylight and monitor, or from vertical fenestration like window and glazing from side walls. Then we have HVAC system in detail, all HVAC system requirements based on your climate zone, like for example, package thermal heat pump or air conditioner, water source heat pump, ground source heat pump, air cooled chiller with DOS, or condensing coiler with DOS, radiant floor, or different system based on your climate zone, as per ASHRAE standard 90.1 and 189.1. Also, service water heating, what is the efficiency, what is the sizing, the location, the acoustic impact from this surface water heating, how we put pipe insulation, black bar also for the office printing and laptop computer, and how calculate the power. Daylighting here in terms of energy efficiency, because as we know, lighting increases cooling load in summer and decreasing heating load in winter. So here we will have IES standard and ASHRAE standard and advanced energy design guides. What is the ballast and the ballast factor? What is the different type of lights like LED, like HID, like fluorescent, compact fluorescent, low sodium, high intensity, all this type, and also T5, T8, and T12 for the tubular, based on tubular diameter. What is the best for you in terms of energy efficiency or illumination? Also here we'll have calculation of daylighting and how you provide occupancy control or photo sensor based on your type of control. As you know, we have to control the wattage or time. We control time by scheduling or by occupancy. For example, if you have office building and you know the employee time, you can schedule your building. So in this way, you provide energy efficiency because you reduce the timing of operation, or you can provide reduction for the wattage by dimming or by efficient lighting like LED. We will have here exposure introduction about different types of occupancy sensor and photo sensor. We have infrared passive type or ultrasonic or dual based on your application. You have office, you have conference, you have warehouse, you have residential, and so on. Also, we focus here on LBD, light power density, based on the area or based on space. Lecture number 5, we're going to cover water conservation in terms of domestic water management, cooling tower system, rainwater harvesting, landscape water, and water recovery and reuse. In domestic water management, we're going to have here the baseline plumbing fixtures inside your building, like water closet, like urinal, lavatory, shower, kitchen sink. What is the recommended baseline values, and based on full-time employee, how to calculate it. We have also cooling tower system. What is the cycle of concentration in terms of make-up water required for cooling tower, the drift from cooling tower, and the blow down. So this one also very important because it's also always coming in the exam. This is the important equation for cycle of concentration, make-up water dividing by blow down and drift. This is the water balance diagram. In order to understand the irrigation and landscaping water requirement, you have to know here infiltration, evaporation, and transpiration. Also, rainwater harvesting, you should know all types of rainwater terminology, like frequency, like duration, and rainwater intensity. Lecture number 6, we're going to focus here on material management, construction waste management, life cycle assessments, LCA, as we mentioned, from cradle to cradle or cradle to grave, area of storage for and collection for recyclables, reduce the impacts of material. Lecture number 7, we're going to focus on sustainable building and sites in terms of design feature to have sustainable site, how to select it, side lighting, urban heat islands, and stormwater management. First, we have here design features like building location, climate, building shape, building size, number of stories, orientation, occupancy type or function. Based on them, you can choose your building shape like H, C, I, E, or different shape based on your requirement, daylighting, or reduction of solar heating. Then we have site lighting and how to reduce it, what's the technology required for reducing site lighting or exterior lighting, and the urban heat islands, the impact of it, how we reduce it by providing landscape and vegetated roof, and how to collect the storm water in sites in order to reuse it, or reduction of runoff, how we can collect stormwater in storage area, how you can provide treatment in order to reuse it, and what is the grey water sources from your building in order to reuse it and reduce potable water. Lecture number 8, it's very important. We're going to focus here on sustainability concept, net zero building. Then we have the benchmarking and metrics, life cycle cost analysis in detail, energy performance measurement using international performance measurement and verification protocol and ASHRAE standard 14 for energy and demand saving measurements, zero energy project success and some case studies. So here's sustainability concept. We have many concepts of sustainability from pre-design to post-occupancy, focused on efficiency, reliability, durability, simplicity, health and safety, and maintainability. All these for sustainability approach, not only a green building. You have to focus on all these approaches or terms in order to provide sustainability every day for your building. Net zero building, different terms for net zero building in terms of energy, CO2 emissions, and water. And we have life cycle cost assessment in detail based on lifetime, 25, 35 years, based on ASHRAE recommendation, how you calculate payback period and the return on investments for different project using package or rooftop or chilled water system, VRF, DX system. Energy management performance, as we mentioned, based on ASHRAE 14 for measurement of energy and demand and water saving based on 3 approaches here, retrofit and whole and reliability simulation. But for IBMV, we have 4 approaches here, option A, B, C, and D, as you see here. And we have to compare between them in order to comply with the measurement of energy performance and energy saving in your building. And also here we have example for energy use intensity based on sites or source for different building types. And we have here the energy end use in terms of electricity. The major part here will be cooling, and for natural gas, the major part will be heating. Net zero energy projects process from pre-design till post-occupancy. What is the requirements? And we have here introduction about energy modeling, how we provide it using different measures. Then we have some case studies in US for offices and in Europe for some sustainable building. Lecture number 9, we have component here of control and monitoring. We're gonna cover control hardware, control strategies, and energy simulation software. First, control hardware for system type, system level, and unit level and building level. What is the BID, proportional integral derivative, and DDC, direct decision control? How you provide each for any control system? What is the methodology and the hierarchy of control? Then we have control strategies in terms of heating, cooling, how we control temperature inside your space, humidity, and enthalpy. And last one, energy simulation software as per ASHRAE standard 140, test of energy simulation program. So the recommended one here should be example like Department of Energy 2, Plus, and Energy Plus. Also, we have many types, other one like ISBE and eQuest. Then here, last lecture to be about commissioning. We're gonna cover here commissioning process, documentation, project management in terms of integral or integrated project delivery. How we commission, you provide commissioning from pre-design, kick-off meeting till post-occupancy, and also operation and maintenance and inspection tasks for any HVAC system as per ASHRAE standard. Okay, guys, so this it was here overview about our lectures. As we mentioned, this is a course outline, 10 lectures, 20 hours. We cover all this. It's more than requirements of the exam, more than body of knowledge required as per ASHRAE recommendation. But as you know, we focus first on the knowledge before examination and certification. So here we'll open here the green guide. We'll take all sections and the contents. Also, we open advanced energy design guide for small to medium office building and retail building to achieve 30%, 50% zero energy. And we have here in detail all case studies starting from building envelope, HVAC system, lighting, power, service water heating, day lighting, and recommendation for each based on your climate zone. Also, we'll open here all different standard of ASHRAE 6.2.1. You will have all the content here in terms of procedure, calculations for outdoor, either hybrid system, natural, mechanical, and how you calculate the exhaust rate, outdoor air ventilation, and what is the air class, because all of them, it will come questions in the exam. Also, we open thermal comforts here, 55. We'll take the three methods, graphical, analytical, and air condition, naturally controlled air. Here also we have the form by ASHRAE for energy cost budget methods, how you comply with it. And you can use this form easily for your project to see you comply or not based on the baseline and the proposed design. Okay, guys, now we completed the course introduction. We advised you if you have a high experience in high performance building, net zero building, energy sustainability, you can be prepared by yourself, but it will take a long time. You can refer to ASHRAE Candidate Handbook with all this required reference as we explained today. Or you can register for our course. It will be started here. The first batch already completed. It will be starting 14th of October. It will be live through Zoom. So you can register for the next batch after it in order to prepare for the exam. If you are interested, please let me know, or you can visit our website here, or you can contact me. You'll find my contact in the website. Thank you so much for watching. If you like the video, please share it with your friend or colleagues. Subscribe to our channel, and if you have any comments, I am free for any questions. You can ask any questions on the YouTube by comment to this video, or you can contact me directly